This is kind of putting everything we've talked about all together at once when you take the quiz and test. It won't be all like that. It'll be this section just focuses on graphing. This section just focuses on substitution, elimination, and then word problems. But for substitution, we need to take one of the equations and put it into the other. The easiest way to do that is to find the variable that is by itself or has a negative. Solve for that variable. So we would subtract 3x on both sides to get that y by itself. Take that equation, the negative 3x plus 5, and put it in for y in the other one. So solve for a variable, substitute it into the other equation, solve for this variable. So this would be negative 5x minus 12x plus 20 equals 3. Combine your like terms and get rid of the 20. So I kind of did that both at the same step. And then get x by itself by dividing. Shouldn't have been no solution because we none of the variables canceled. So once you got 1, you should have put that back in to find y. So then our solution would be 1, 2. Did we have any questions on that one? Remember, as you're practicing, you can pull up Desmos, put these in there, see, does your solution match? If not, something's wrong. For number 2, you need to graph both of these. So I'm going to graph them in 2 different colors. So for the first one, start at 5. Slope is negative, so go up 1, left 2, fill up your graph. And then down 1, right 2, fill up your graph. And then do the other one. Be careful with the second equation because these are switched. If you wanted to rewrite it, you could. But you're starting at a positive 7, and your slope is a negative 1. So we're going to go up 1, left 1, and then down 1, right 1. So then your solution would be at 4, 3. So as long as you graph your lines correctly and they're already in y equals mx plus p, you can use your calculator to double check that. Questions on that one? And then for the last one, your elimination process. Remember, the rules are a little different. You're not substituting an equation in. You're trying to find common coefficients, which we don't have. So you have to make common coefficients. The way you did this may not be the same way I do this, and that's okay, as long as you get the same answer at the end. So let's say I wanted to get rid of my x's. I'm going to multiply my first one by 2. By 3. And the second one by 2, so that my equations change. 12x plus 15y equals 18. and 12x minus 14y equals negative 40. Now I have common coefficients. Now I can get rid of them. The only way I can do that is if I subtract. But remember, we're subtracting the entire equation. So the x's cancel. 15 minus a negative 14 becomes a positive 29. And then 18 minus a negative 40, we add those. So 58.
Why are you adding?
18 minus a negative. The minus the negative becomes a plus.
So you got rid of the 12 minus, and then I thought you were supposed to always subtract it.
We're subtracting everything. But 18 minus a negative
So
would
we
make
get
it
14 minus negative 14.
I'm assuming that's 2. And then now that you have y, go back and find x. Put that y value into any of the 4 equations you have. Does not matter which one. So let's say I choose the first one. So we have 4x plus 10 equals 6. Solve for x. So that x equals negative 1. So negative 1, positive 2 would be our solution. Do we have any questions on that one? Chris?
When you get y, do you still take either one of the equations?
Yeah, so you can use this one, this one, this one, this one, doesn't matter. Any other questions on that one? 4 is a good check yourself. Remember how to check yourself, so if you want to do that later, you're more than welcome to. And then 5 is a good thinking problem. It gives you an equation. It asks you to write an equation that would give you, at the end, a solution that would have infinitely many, so you'd have to know that. So again, you could try that if you so choose. Did we have any Khan Academy questions? As always, the first thing with a word problem is to find important information, so we're going to read it. Read it together with me, either on the board or on your paper. A snack bar sells large and small nachos. Large nachos cost $5 and a small pack of nachos costs $3. In one day, the snack bar sold 60 packs of nachos for a total of $220. Let L be the number of large nachos and S be the number of small nachos. Write a system of equations to model the situation and determine how many large and small packs of nachos were sold. Important things. What do we find important? The cost. So the small costs 3, the large costs 5. Those are important. Taylor?
The L being large nachos and S being small nachos.
Okay, so they told us what our variables are, so that is very important. As in the total. Taylor?
Number of packs sold.
So anytime you see numbers, all of those are important. Last unit, when we talked about word problems, there was one type of word problem when you were comparing two different things and you use a specific equation, that ax plus by equals c. That is the only equation you're going to use here. So that's nice, because you don't have to remember different forms, with some exceptions, but we'll talk about those. So as with last time, we have to define variables. There are only 2 variables you need to define for me for this, and those are the 2 things you don't know. Now, here they defined it for us, but moving forward, some of them may not. In a question that doesn't, you would look at the question. The question asks how many large and small packs of nachos were sold. Those would be the two things we don't know. So I would write two different variables, doesn't matter what they are, but this one they told us. So L would be the number of large nachos, S would be the number of small nachos. And we're going to be specific. If you want to say nacho packs, that's fine. So we've defined our variables, even though they were already defined for us. But we need to get in the habit of doing that every time. I know that because we're comparing two different things, large and small nachos, we're going to be using the equation that looks like this, but with different variables. L and S could be your A and B or X and Y. It does not matter. I would say probably X and Y more so. Because I don't know if you remember, but when we had a problem that was like this, the very first time we did the word problems, that last unit, I said that A and B are always given. So here, if we look at what is related to the large and small nachos, we're given the cost and we're given this both costs. So those given numbers we can say are our A and our B. So knowing that information, how would we write or start writing one of our equations? Looking at the costs, looking at the variables we have. That's a good question. So for this, because this one is going to include our costs, we have to look at which of these totals represents costs. So which one would we use? Does the 60 represent our total cost? No. So the 220 is going to be what it equals. And then we need to use our L, our S, and the cost numbers.
3x plus 5l.
I'm going to try and make this S not look like a fire. That should have been a 5, not a 3. My bad. Okay. Remember that we are still dealing with systems of equations, so we need 2. We are given another total, the 60. 60 represents the total number of packs. What else do we have that represents the total number of packs? Go. So if we're looking at the things we have, what else represents the total number of packs? Besides 60, what else represents number of packs? Chris? So we can't use the 3, the 5, the 220 again in the second equation. Has to be something else. Something in this says number of large packs of nachos, number of small packs of nachos. What do you see that says that? Highlighted and written again. It is the SML. This is the part that's a little tricky because you have to think about, okay, what should I be putting this with? Because you have to have two equations. One of them is going to deal with the numbers you're given. One of them will have one of the numbers, but then won't have anything else. It'll just have variables. Sometimes. Sometimes there'll be numbers with everything. It just depends on the problem. Alright, so now we have two equations. And again, as I said before, you have three options. Solve by graphing, solve by elimination, solve by substitution. So for this one, we're going to solve by graphing. If you don't have your calculator, go grab that. When we solve by graphing, especially in your calculator only likes the variables x and y. So we have to change these to x and y. So I'm going to say that my s is my x and my l is my y. It does not matter if you switch those as long as you keep it consistent. And then I would need to change how both of these look so that it's solved for y. So for this second one, that's not that bad. I can just subtract. I have y equals 60 minus x. For the first one, though, I would need to get rid of my x term by subtracting. So 5y equals 220 minus 3x. And then divide everything by 5. Divide 220 by 5 and tell me what that is. Say that again. 43. So if you're solving by graphing, I need to see this work, but after that you're going to put it in the calculator and let the calculator do the rest of the work, and you would just say use the calculator or graph it in the calculator. So in your calculator, we're going to go into y equals. If there's anything there, clear it out. And we're going to type in those two equations, 16 minus x and 44 minus 3/5 x. When we usually write equations, we usually switch it, but for this, it doesn't matter. Alpha y equals. Sure, doing this. So y equals, type both of these in. Yes. Minus, yes. If you put a negative, it would multiply it, so just put minus. Right. And then you're going to graph them. If you don't see your graphs, like mine didn't show up, let me also make sure that it was on. Yeah. You may need to zoom out. So I'm going to go to zoom and then find zoom fit, which is 0. Zoom fit. These will eventually cross, but not in this. So So I might need to zoom out again. There we go. Now I can definitely see that they cross. If you can't see that they cross, the calculator won't do this work. So I zoomed to fit, and usually that works, but it didn't for this time. So I zoomed out to 3, and then just hit enter, and then it'll zoom out. As long as you can see that they cross, you don't have to keep zooming out. But then once you see that they cross, second trace. And then you're going to find where they intersect, number 5. And then hit enter 3 times. And it'll tell you that intersection point. So x equals 40, y equals 20. If you didn't start off with the variables x and y, you will have to tell me what both of those things are. So we have to go back. X was S, so S equals 40 small packs. And then L is 20 large packs. So we have to be specific in our labeling for our answer and defining our variable. Because we did this by graphing, you would say graph and calculator. That would be your work after you solved it for y. Some equations will be easier to graph than others. Some you may not want to do all that work for to graph it. That's why there are 3 options. What questions do we have on that? The next one, we're not going to do the very next one. Skip to example 3. Take a second, go ahead and read that. And then we'll come back and talk about important things. I feel like I made this as when you were a freshman, yes. Here's my iPad. And I just didn't change the name. Did you already send it? Come on. This makes sense. I'll try it again because I don't see it. And then just let me know when it's sent.
Cool.
Okay. What did we find that was important? What in this did you find was important?
5 pairs of earrings.
Okay.
5 pairs, 2 pairs of shoes for $30.
Okay. Anything
$2
else?
$2 more than 4 times
Taylor?
Eating the cost of earrings, and that's the cost of shoes.
Okay. Pay attention to what the problem is asking to, because sometimes you won't need to solve for both. Sometimes you just need to solve for one. It depends. Most of the time you solve for both. So. Okay. So let's define our variables. They defined it for us, but if we didn't know, we'd be looking for the cost of a pair of shoes and the cost of a pair of earrings. This one's going to be written a little bit differently because it's specifying something about the pair of shoes. It says each pair of shoes costs $2 more than 4 pairs of earrings. So this is going to be, we're going to start off with E equals 2 more than 4 times the cost of earrings. How would we write that? Not 2 times. More than. What operation would that be? For not multiplying for more than, what operation do we think that would be? Addition. So 2 plus 4 times the cost of earrings. How would you write that? No, we're not multiplying 4 times something. What are we multiplying by? What represents the cost of earrings? Oh, also, it should be S. Not, that's my bad. Okay, so we have one of our equations, we need the other. The numbers that are given are going to help us find our other. 5 pairs of earrings, 2 pairs of shoes for $30. How would we write that? It's going to be in the same format as the last problem.
How did we get the 4?
It says 4 times. It was in that problem. 5 pairs of earrings, 2 pairs of shoes, $30. How would we write that equation? If it has to be in the AX plus BY equals C format. Sometimes the setup of these equations, you'll notice, are better for some things than others. Because you have an equation that there is something solved for a variable already, which method would probably be best to use here? Chris, what did you say? When you say the first one, what are you talking about? Which of the 3 graphing, substitution, or elimination methods? So we're going to substitute this equation in for S. And then continue to solve. So 5e plus 4 plus 8e equals 30. Combine your like terms. And get rid of 4. Divide both sides by 13. So that E equals 2. And we're labeling this as our answer to what? What does E represent? Here, the cost of a pair of earrings. So dollars. Then we can use that to find our S. I'm going to use the equation we found. The S equals 2 plus 4e, but we know e is 2. And solve. So then, by substitution now, we have solved this word problem to find both E and S. A lot of the word problems you'll see are easier solved by elimination. This one, substitution probably would have been better because it's already solved, but it wouldn't have mattered. What questions, confusion, anything like that do we have on this problem? We're going to do 3 more problems. One of the ones I want to do is on this maze, so there's not really space for you to show work. There is space on the back, but I don't know if you want to keep flipping back and forth. If you want to write it, like open it like this and write it on example 4, that might be better. We're just going to do this first example, and then if you want to continue the maze for extra practice, that'll be up to you. So for this first example, read it, find important information. So we have so far important things: 4 fountain drinks, 3 bags of popcorn for $22.50. What else?
5,000 drinks and 2 bags for 23.75.
And then what are we looking for? Alright, so in this problem, we are only solving for one thing. So I'm going to show you, if you happen to solve for one thing, the fastest way to do that. Also notice that there are 6 numbers. That means when we set it up in the ax plus by equals c format, you'll have an a and a b and a c for both equations. Now we just need to find variables. So we don't know how much a fountain drink is, which means we also don't know how much popcorn costs. So we're looking for costs. I can do this one. Where is the thing I'm looking for? This. Okay, so define your variables first. F and P, D and P, X and Y, it doesn't matter, whatever you want to call them. But be specific, we're looking for cost of each. With every problem, you have to define 2 variables. You have to have 2 equations. You have to show how you solved it to get both pieces or one. Yeah. Oh. So then, using our numbers, how would we write our equations? Okay. That would be the first one. If you use different variables, just make sure your variables match. And then for the second one, what's nice is all of your problems will usually be set up the same way. So then, we're going to solve this one by elimination. Because we're specifically trying to find fountain drink, we want to eliminate the cost of popcorn so that all is left is fountain drink. So we're going to eliminate our P's. We solve for F. Right now they are not the same. How would we make them the same? Multiply the first one by 2, the second one by 3. We have 8F plus 6P equals 50 something. Multiply that, tell me what that is. 2250 and 2. I may have limited that. It's 40.
22
Times 2.
45.
And then 15F and 60, and then 2375 times 30.
71.25.
So, yes. Did you do the press? Yes. Huge now. So now, to eliminate our P, we would do what? Someone said it, a very tired way. So we'd have 8 minus 15 would give us a negative 7F. You would cancel. 45 minus 71.25 would give us what? So, not 10. Point 25 or 0.75?
35.
Oh, you money.
That may have did it. Negative 26.25, is that what we all got? Yes. Okay. And then divide. Which, if you look back, that is one of the answer choices. So if you're doing the maze, that is the direction you would go. If it asks you for both, you would go back and solve the other one using that. Always look back at your answer. Ask yourself, does this make sense? Could I get a decimal? I'm looking for cost. Yes. $3.75 is a reasonable price for the things. If I get a price and it's 25, that probably wouldn't make sense because my total is more than my total. So look back at your work. Look back at your answer. Ask yourself, does this answer make sense? Okay, questions on that one? Okay. Find this leaf. So these are the last type of word problems that you may come across that may challenge you. We should talk about the definitions a little bit. Because these problems are all about flying or boating down a current, down a stream, down a river, something like that. So you need to know these things. If you are flying in a plane, if it says the words into the same wind, it's flying against the wind. If it says with the wind, it's flying like in the same direction as the wind, like the wind is helping the plane, it's pushing it. So with the wind, you're going to be adding. Into the same wind, you're going to be subtracting. It could say something like tailwind. That would be the same thing as with the wind. The tail is pushing the tail of the plane, so you're adding it together. For a boat, it's kind of the same thing. If you're going down Yeah, if you're going down the river, usually the speed might be faster unless it's talking about the stream, so you're adding. If you're going up a river, you're usually going against the stream, so it's subtracting. Or if it says with the current is pushing the boat along, so you're adding. Against the current, or against the same current, you're going in the opposite direction, so subtracting. So you'll need to know the difference between those. But let's do this first one. So flying a plane, or flying with the wind, a plane went 369 miles per hour. Flying into the same wind, the plane only went 325 miles per hour, excuse me. We have to find the speed of the plane and the speed of the wind. So the two things we don't know, the speed of the plane, the speed of the wind, those are going to be our variables. I'm going to call them P and W. For the speed of the plane, or the plane speed, and the wind speed. The two numbers they give you are going to be your totals. And then if we're flying with the wind is pushing us along, are we going to be adding or subtracting these variables together? Adding. P plus W. Flying into the same wind, we are going against the wind. The wind is no longer helping us, and now we are subtracting the wind speed because the wind is no longer helping. All of these type of equations, or these problems, the boating, the planes, will be set up like this. And then we can solve. So whether you want to solve by graphing, substitution, elimination, it's up to you. I'm going to pick elimination because it's set up like an elimination problem. We have common coefficients. Do we want to get rid of P or W first? It does not matter. So I'm going to pick one. P, W. P. Okay. So if we are getting rid of P, what operation are we using? How would we eliminate P? Subtracting. So W minus negative W, that becomes a plus. The P's cancel. 369 minus 325 would be 44. And then solve for W. Again, label your answers. Here we're dealing with miles per hour, so that would be our label. Be careful because they're not all miles per hour. Some are kilometers per hour or whatever. And then we can go back and find P. So pick whichever equation you want, put W in, and solve for P. These are small enough or easy enough equations that you could put these back in and double check does this work. 347 plus 22 equals 369. 347 minus 22 equals 325. You could quickly do that to double check. Just like the other problems, ask yourself, does this make sense? if you get a number that's really big for the wind speed, that should not make sense. In theory, unless there's like some natural disaster, your wind speed is going to be way less. Same thing with your boating. Your river speed is going to be way less than the speed of your boat. Questions on that one? So let's do this next one and then I'll stop talking. So for number 2, we're going down the river, and the boat went 13 kilometers per hour. Going up the river, it went 3 kilometers per hour. We need to find the speed of the current, or the river's speed, and then how fast the boat were going if there were no current. So that's really the boat's speed. So if I wanted to define those variables, I could say C and B, X and Y, it does not matter. Try not to confuse this wording. Think about what it's actually asking. The speed of the current is the river's speed or the current speed. How fast would the boat go if there were no current is really asking about the boat's speed. So those are the things we don't know. Using the previous problem, how would we set up these equations? What do we think?
C plus B equals 13. C minus B equals 3.
Okay. So this is really confusing. Are we subtracting the boat speed to get this? Or are we subtracting the river speed to get that? The river speed. So be careful how you write this. So this should really be B minus C equals 3. So if you want these to line up, you can change the order of this. The adding you can write no matter what, in whichever way, but the subtracting you can only write one way. So if you switch them, your full answer becomes wrong. Alright, do we want to get rid of B or C first? Does not matter. You guys choose. Eugene, pick one. B or C? Okay. So if we're getting rid of B first, we would do what operation? Subtract. So your B's would cancel. C minus a negative would become a positive 2C. 13 minus 3 would become 10. Divide. So this is kilometers per hour. Put that in to find your B. Subtract 5 on both sides. Again, really quickly, I can add 8 plus 5 gives me 13. 8 minus 5 gives me 3. So that works. Let me know when the pass goes through.
It says March.
Okay, give it like a minute or two. Okay. Also, my vote speed is bigger than my current speed, which should happen. Do we have any questions on that one? So you have a lot of different things you could practice right now. One being any of the word problems in this packet. I would say definitely make sure you're good on the voting and planes, and then maybe some of the others. You have a review. Maybe do one problem from each page so that you remember and are good with all of those. You have Khan Academy that is due on Friday, so you all have something you could be working on. Make sure you're actively working. Your quiz is next class. Your test is Friday. So make sure you are good with this stuff, practicing this stuff, and letting me know if you have any